My name is Max Klymyshyn, and I'm going to talk about property-based tests. Uh, so, a lot of people. Who knows what this property-based test is? Okay, cool. So, my talk is like about very basic stuff, but hopefully it will be useful for you. A couple words about myself. I'm currently working as head of software architecture at Tech12 Technologies. Before that, I worked for Zakas and a couple startups. I'm Python programmer, I assume. Also, I organize couple events in Kiev and other cities, and help in this organization of this event. So I know a bit about stuff. Oh, looks like something goes wrong with my slides. I'm working for Tech12 Technologies, and we are making the. You can see the text, but actually we are making e-grocery delivery with a robotic warehouse. So, yeah, if it's possible, it will be great. Thank you. I think it slides a bit. Super, thank you very much. So, robotic warehouse, it should look like this. We're currently building it. I'm responsible for software, so I will talk about software. This is how typical dev process looks like in typical company, I assume. So you have requirements, and afterwards you making your specification in some form. Afterwards, making development and testing software. So it's interesting because Python have like good culture to write unit tests and all kinds of tests. I think there's a lot of tools for testing in Python because QI engineers using it a lot, like bindings for Selenium and so on. The quality of tests on average, like higher for Python code. Before I will dive into property testing, I would like to say something about correctness. Who knows what correctness is? Correctness. Software engineers, correctness. No? Okay. Basically, it's the property of software that the software met specification. So if you write some function, you write it before you have requirement to write it, and you have defined inputs and defined outputs and some logic inside. And correctness is that it met specification for this particular functionality, and so on. And I would like to provide an example from another universe. Everybody knows what JavaScript is. Okay. This is a very simple function. We make exponent, right, in English. So we have some number, okay, and it looks good. And we add in 1. And the result is some number. And it says nothing, right? But this example is much more expressive, right? It looks actually like amazing. So the correctness is about things like that. Sure, feel free. So if you don't know about this stuff and you make some calculations with these numbers, you will fail eventually, and you will know about this stuff. So, okay, let's go back to property-based tests, or so-called generative tests. This thing starts with a tool called QuickCheck, which was developed, or which it was a paper written in 1999 and for Haskell to simplify testing and to make some kind of better tooling for Haskell. So basically the idea is that you get in some input and you define in the type of your input, and property generate a lot of different kind of stuff with type you specified as input and provide to your function. So here's simple Python function. Everybody understands what is it, right? So this is very basic stuff, and this is very bad unit test, but it works, like it does what expected, and it will not fail. Okay, so and this is how this is like I refactored my simple function. So like if input more than 10, then different formula applied. So my unit test still works, but the function does absolutely different thing. Oh, I missed the slide. So it's senseless. Okay, so this is how test with hypothesis looks like. So I define the test and input as integers, and there is some call, and I assert the like the property of my function. And after I run hypothesis, I will get this thing, because when my value is 10, then it will fail. So is it clear? Yeah, cool. Sorry, I missed the slide. So this tool called hypothesis in Python, and you will get basically some useful tooling to generate your data for your functions or set of functions. So basically, instead of just asserting data which you in basic unit tests, data which you think will be useful to assert for using hypothesis, you specify in your input data types, and hypothesis generate data for you. And also you have like some assertions about output, so you should put something useful in your output. Hypotheses have things called strategies, so you not just specify like this integer or floats or text or so on, but you specify in the strategies how to generate, so you can provide ranges of your data, so like some boundaries. So also you can change strategies, and you can generate recursive data like graphs, or I don't know, some very deep dictionaries, and you can composite different strategies. I will not dive deep into hypothesis because everything is available obviously on hypothesis documentation. I just want to provide some basic idea about that. And I assume this is the moment where everything should be understood about idea of hypothesis. If you don't understand, I would like to know about that. Everything is clear? Super. So this talk is basically about ideas how to make hypothesis useful, because when you have such a powerful tool to generate data and so much possibilities. It's hard to imagine how to apply it to things which you have on day-to-day basics. Like you develop new functionality and you have such powerful tool, and there is actually I think there's I think hypothesis is limitless. So therefore I would like to provide some ideas which we already employed or we want to develop in our company. So everybody knows what traforet is. Traforet, input validation. Okay, a lot of people. Cool. So this is some kind of model of, for those who don't know what traforet is basically a tool to validate your input, and also you can transform your input. And for my talk, I use only validation part. Like you have dictionary with some structure, and structure is with fixed keys. It's kind of named tuple bar, but with batteries. And also, additionally, there is ID which represents type of reference. So you can have hypothesis, or you can have traforet model, and you can define relations between different models, different inputs. And hypothesis generates some kind of this input. So this particular input is not so useful, but it gives some idea how hypothesis works. Hypothesis want to generate, if you not limit input, want to generate any random data. For example, here's a lot of Unicode in emails and so on. So if it be applied to your, for example, REST API, your REST API will blow up, I assume, something like that. But it can be very useful. So in case you use some kind of tool which can where you can describe your data models, your structures and relations between structures. For example, in Django, you have models and foreign keys, but in document-oriented databases, you don't have such possibilities, so you use some kind of marshmallow or traforet with this example I provided, or any other stuff. Basically, this is graph of different models. So if you have this, you can generate your data, your trees of your data without any fixtures, without a lot of efforts for generation or for housekeeping those data. Also, as a plus for Django models, there are already plugin for hypothesis, so hypothesis can generate Django models. And the main benefit of such approach is to not maintain big relations, big fixtures and relations between fixtures. And if you change one fixture, there's 50 tests failed and so on. So hypothesis can do it for you. For example, if for your particular functionality there is only 2 properties of your data is important, you can generate with hypothesis whole bunch of nested data set, and only couple properties, couple params can be changed. So you can generate meaningful information for that. And you don't need to maintain this huge JSON or so on. So it's kind of fuzzy test when you generate a lot of binary tests, but it's also typed. Another idea is to use Open API. Because in Open API there is definition of input model and output model. So the thing which is lack is relations. So if you add some specification to extend Open API specification to represent relations, you can generate data using just definitions of your Open API inputs. And it's possible with hypothesis and such kind of tool. So here is example of nested model. So this is just absolutely dumb example. Like you have zip codes and also model from couple slides before with user, and here's address which have one-to-one relations to user, so user ID is meaningful in this, and zip code it represents a relation to this field code. So as you can see, you can generate nested data using hypothesis with like very less effort. This is example of generated data when you have relations. So basically, a couple words how we use hypothesis in our company. The idea to use generative testing came from Clojure, because we have in our company have Clojure and Python, and there is core test check, which can generate data for you when you specify it. So we tried why not to employ this same approach to Python, and there is hypothesis, and actually already using it to generate complex data. For example, whole picking process, which is a lot of like 15 models generating two hypotheses. So they are these complex relations. So it's quite useful, and there's not much efforts to support this data. And also the idea which you want to employ is to generate input for REST to create end-to-end tests. So basically that's it. Very basic stuff. Do you have any questions?
My main question is, how do you guys connect the Traforet with hypothesis? Because I don't know, you showed like a couple of examples how you defined it, the Traforet, and then say like, hey, hypothesis generate these like structures, but how it's connected? Did you implement some sort of plugin for hypothesis or what?
Sure, yeah, it was yesterday. So yeah, I implemented very small, it's really small, the mapping between types in Traforet and strategies in hypothesis. So it's very easy, like you go through keys and generate data for each field. So it's like 20, I don't know, 10 lines of code.
Did you release it on GitHub?
Not yet. Is it? It's more about ideas, because as far as I know, there is not such thing besides Django models which can provide meaningful generation of dictionaries with some useful data for Python. So you need to write it by yourself, and I don't want. So any other questions?
Yes. Do you know how many samples the hypothesis generates? So for instance, you tell it, I will test integers. How many integers will you actually take?
It depends. You can specify explicitly. There is no one answer to your question, because if you have assumptions, then you generate some samples and then get rid of samples which not match your assumption and so on. So it's completely it's defined through settings.
I was going to say the problem is for test suites that take time. So for instance, if your test suite take half an hour, you use hypothesis, it will take like 10 hours maybe, And
absolutely, yeah, this is a problem. It's why I mentioned the limits and assumptions.
Hello, thank you for a talk. If I understand that right, correct me if I'm not. You was started with that correctness definition, and these hypotheses and strategies can actually run the code against any different combination of the data. And actually, for which kind of testing would you think it's going to be useful? For stress testing and regression, like your code after some changes will be available to serve all the data? And how do you use that idea in your work, like day by day? And which tests are like suitable for this? I just suppose that the logic and the code should be tested by different kinds of tests.
Okay, so a couple of questions. First of all, where it will be useful. I assume that it will be useful everywhere, but the only problem with this hypothesis is that it's time-consuming. So you should limit your test cases because it will take forever if you have a lot of tests. So basically, you want to test your code on all possible inputs, if it's possible physically.
Let me
not
rephrase that for a moment. Which kind of application do you think have such high quality requirements to check any different, like a combination of the input?
Okay, it's not a yes or no question.
Yeah, but what do you think? What do you think?
Yeah.
How often do you work on
I
this
think
kind of
that
application?
I think that the reason why I mentioned correctness, it's to not spend time on bug fixing. I want to make my soft like correct from first time. At least I want to make effort to do that instead of fixing it. So I would like to write once and go to next feature and never go back. Basically, this is why I want to make correct software, because I don't want to go back and refine.
This is regression testing. Yeah, thank you.
Yeah. Any other questions? Super. Thank you very much.